So I'm just going to do a quick example for converting a fraction into a decimal. I know that in the exam and in the assignments you'll probably have your calculator and you can just do this sort of question on your calculator, but I think it's worth looking at the process so that we can understand why it is that some fractions result in recurring decimals and how that, why is it that certain fractions result in decimals with a period of 2, why does some have a period of 3, etc. So I reckon it's part of understanding that. So I don't have a decimal fraction here. It's not something over 10 or something over 100, which converts straight into decimals easily. And it's also not something like, 3/25, which could immediately go into 12 on 100 because 25 has 100 as a multiple. We know that there are no multiples of 11 that are 100, 1,000, etc. So I don't have any shortcuts for doing this. I just have to do it as a division. And so I do it as 14. Think of this fraction as 14 divided by 11. So setting up my division here, I'm going to do it as a long division. Some of you might recall this, for some of you it might have been a while, but when I'm doing a long division like this, one of the things that I can start with is just listing my multiples on the side here, just so that I don't have to think too much while I'm doing it. And I just need my multiples up to 9 times 11. Okay, so the first step that I do is I divide 11 into the tens column. So implicitly what I'm saying is 10, how many lots of 11 tens? But in general we just think of it as 1 divided by 11, which gives me 0. And because I haven't divided anything in there, I have a remainder of 1. So this subtraction here is just explicitly working out what the remainder is. It'll become clear as we do more questions. So I have the remainder of 1, and I now bring down my 4 because I'm going to start dealing with the units. And I say 11 into 14 units, and this gives me 1. And 1 times 11 is 11, so that means that my remainder here must be 3. Now at this point, that was in my units column, and I'm now going to put in some placeholders just so that I can continue the division. So I put in zeros here, and I'm bringing a 0, bringing this 0 down here, so that I now do 11 into 30. So basically, my next step will give me an answer in the tenths column. So 11 into 30 goes twice. 2 times 11 is 22. And there's 8 left over here. So at the moment, what this is saying is, when I ask how many 11s in 14, there's one whole lot of 11, and then there's 2/10 of an 11, and then we're still going to have a little bit more that's made up here. And so bringing the 0 down, divide 11 into 80, and this goes 7 times. 7 times 11 is 77. And so this gives me a remainder of 3. And so now, bringing the 0 down again, 11's into 30, and I notice here that I'm going to start getting into a loop, because I'm going to have 11 into 30 goes twice, 2 times 11 is 22, and I get a remainder of 8. So each time I'm going to divide 30 and get a remainder of 8, and then I'm going to divide into 80 and get a remainder of 3, and then I'm going to divide into 30 and get a remainder of 8, and the process is going to continue. So at this point I have to recognize that this is going to be a recurring fraction where the digits 2 and 7 keep on recurring indefinitely. So my overall answer when I divide 14 by 11 is 1.272727 recurring. And I can represent this as, might just write it explicitly here, can say that 14 over 11 is equal to 1.27, and I can have a recurring at the top like this, or I can also think of it as can maybe write it like this if I want as well. And so that just means that the 2 and the 7 is this recurring block that will repeat forever. So that's converting a fraction into a recurring decimal.